All right, well, let's get started properly then. So welcome everybody to another webinar from us. We're doing these once every 3 weeks on various different topics. Today's topic is on air conditioning control. This was the most voted for topic the last webinar. Now, what we're going to do is going to be a little bit special today. This lovely new building that we're in has an aircon system. We have 2 outdoor units, one for the ground floor, one for the first floor. Each of those outdoor units feeds a number of indoor units. We've already pre-wired the outdoor unit. I've got some pictures of how the wiring is done that I can share with all of you. And we are actually going to get this aircon in this very office that I'm sitting at configured. So I'm going to prove to you that the configuration that I'm showing you works. So I've already got a webcam set up. You can see the thermostat on the wall. That will react to whatever we configure. At the moment, you can see the aircon is currently turned off in this room. It is also very, very warm in here because there are 2 rows of windows and the sun's coming in, which is also why there's glare on the thermostat. Thank you, Adrian, for pointing it out. It's only the left-hand side of the thermostat you need to worry about looking at because that will tell you whether it's on or not and what temperature it's trying to get to. So without further ado, let me share my screen. Just before I do, another quick reminder, if you have any questions as we go along, please just ping them over using the Q&A feature on Zoom. I won't continuously look at that, but when I do, if I can answer it then and there, I will. Otherwise, I'll save it to the end. You can send them over in the chat as well if you don't have the Q&A, but I will look at the chat less often. Okay. So sharing my screen and make sure I share the correct one. There we go. Perfect. So at the moment, I'm just going to make that camera a little bit bigger. At the moment, all I have prepared is I've got a demo case next to me that I've connected to, and I've just saved a basic config file into this. This config file is literally just currently a heating system. So at the moment, I've just got a heating system for a house I've used as an example. That is an S-plan boiler-based heating system. So you can see here we've got our zone valve that we would open. So anyone who watched the heating webinar that I did a few weeks ago, this is pretty much exactly what I've already shown you there. And we're going to expand this system to include aircon as well. And I'm going to pretend that the room that I'm sat in now is the living room. So we've obviously got a boiler-based system in there with a radiator in that room to do wet heating system. And we're going to bring in an aircon system that could do heating and cooling. And that is how we're going to roll with this. So hopefully I will be able to show you how to integrate through several methods into an aircon system. The method in particular that we're going to focus on though, because we have it in our office here in the UK, is Coolmaster. So Coolmaster is an integration unit, funnily enough, made by Coolmaster. This company here is the UK distributor for it, 10 Ways. And it is that particular model that we have in our office. It has, I think, 7 different lines that you can connect up to 7 different aircon units. And it speaks either Modbus RTU, which you would use a Modbus extension for, or Modbus IP. Great thing about Modbus IP, no extension required, only the mini server. And that's how we're going to do it today. We'll use Modbus IP. Now, the other cool thing is, even though that's 7 lines for up to 7 different aircon units, if you wire that line to, say, an outdoor unit, you can control every indoor unit connected to that outdoor unit. I believe up to 64 indoor units per outdoor unit. So in this office that I am sat in, we have in total, I think, 22 indoor units across the entire office spread across 2 floors. And we can communicate with all of them through 2 connections from that Coolmaster unit. So that's really cool. No pun intended. The other potential we have for integration that would be my other choice would be a unit called Intesis. Very similar principle. You want a Modbus integration unit. So we speak to it over Modbus and then it speaks to the aircon unit. Now, the relative pros and cons of each. Intesis is a fair bit cheaper than Coolmaster. However, Intesis is designed to speak to a single unit generally. So for instance, if we were going to go for one of these Daking integration units, it would speak to a single Daking AC unit. You'll also notice that the other con with Intesis is that you get a model specific to the Aircon system that you want to talk to. So it's very, very specific. You speak to one unit and you have to pick the correct module for that unit. But the pros is that it's quite a bit cheaper. And the second pro is that the config is quite a bit simpler. Because you're only speaking to one unit, you only really have 4 or 5 registers to worry about. By comparison, the Coolmaster unit is better for larger systems because you have those 7 lines straight off. So you can speak to up to 7 different units. And by units, that could be a single indoor unit, or that could be one outdoor unit that connects to multiple indoor units. It's also brand agnostic. So that single unit there can connect to a Samsung system through one of the lines and a Daking system through another one of the lines. But the con, it's quite a bit more expensive. I think it's about 5 times more expensive. So there you have the comparison between the two. For us in our office in the UK, that particular unit is a no-brainer because of the number of indoor units that we have. So then moving on to the installation side of things, it's a lot simpler than many, many people assume. On both the Intesis and the Coolmaster, the fundamentals are exactly the same. On the air conditioning system, you have a couple of connections. On the outdoor unit, it's usually marked up as R1, R2. On the indoor unit, it's quite often marked up as L1, L2, or L3, L4. So it's basically just a pair, 2 connections. Usual way of connecting is, I've got some pictures here. This is where we get really cool. You can just connect straight to the back of the thermostat. So if it's a single unit or maybe it's a bus of indoor units, you could just connect it on the back of one of the existing thermostats. FYI, I did not do any of the wiring in this building, so don't start talking to me about having terminals or ferrules or anything on these connections. So I could just connect an Intesis or a Coolmaster unit onto those 2 connections there and speak to this indoor unit. If you want to speak to a large number of indoor units connected to a single outdoor unit, then what you want to do in that instance is obviously connect to the outdoor unit. Now you take the panel off the outdoor unit, and inside there, I wouldn't recommend doing what I did, which was taking the lid off when the unit was still powered up, because it is quite scary because you have a giant metal blade spinning at about 1,000 RPM above your head. And I was very, very careful not to get decapitated. But inside the outdoor unit, again, you've got some connections. F1 and F2 is the bus that connects through to the indoor units. So it goes from one to the next, to the next, to the next indoor unit. There is also 2 additional connections specific to a Samsung unit, R1 and R2. And that is what the Coolmaster connects to, R1 and R2. So you take R1 and R2 and you cable it to one of the lines of the Coolmaster, which you can see in this picture here. As I mentioned, we have 2 outdoor units, hence why I'm using 2 lines. And yes, I did do that wiring. Yes, I'm using Cat5 and I've doubled up the pairs. The reason being is because that is the only cable I had left in the office and I wanted to get us some working aircon. Don't worry, it will be replaced at some point. Probably won't be. So 2 outdoor units, 2 connections from there to R1 and R2 on each outdoor unit. Once you've connected it to the Coolmaster, the other specific things on the Coolmaster is you would need to go through the settings on the unit to say what models you're using on what line. So you can see the different lines there. We're using line 4 and line 5. So in here, I would change line 4 and line 5 to say Samsung. So that's the make. And then you'd have to put in the Modbus settings as well. Then once you've done both of those, in one of those setting options, there is a button that says Run VA List or Run VA Auto. Now, VA is virtual address. And the way that the Coolmaster works is it assigns a virtual address for every indoor unit. So you run VA Auto, and what it does is it auto discovers every single indoor unit that you have connected on those lines, which you can see here. So you can see on line 4, which is our upstairs unit, it has found 11, 10, no, 11, because it starts at 0. So it's found 11 indoor units on line 4. And on line 5, I think it's another 11. And then for each indoor unit, it assigns a virtual address. Now, the virtual address is important because that is where your Modbus registers start from. The other nice thing about the Coolmaster is the display of it shows you the current status of every indoor unit and also allows you to turn every indoor unit on and off. So you can do some testing and diagnostics. For instance, in this office, no paperwork came along with it. No idea which indoor unit was which. So on there, I just turned them on and off one by one and waited to hear which one turned on. This number here as well, that you see next to the virtual address, is the feedback code from the Samsung unit. So you can see here on address 3, we've got a code of 152. And that's an error code. I think it means like condenser is broken or something. So it gives you really, really good feedback. So that's all the wiring, all sorted. Next, we get onto the config. So this is where I've been really daft. And I can't remember what IP address my Coolmaster unit's on. So bear with me 1 second while I just quickly remind myself of what the IP address of the Coolmaster unit is, which I should have written down before we got started. Just going to look at it on my other screen because I've obviously all set up the IP address already. Coolmaster hut should be on this address. So ping 10.74.2.19 and something responds. Perfect. So hopefully that's the one. So configuration then. This is Modbus. This Coolmaster unit in particular is Modbus IP. So the first thing that I need to do is I need to add in that Modbus unit. Modbus IP devices are added into the periphery list under network periphery. Under network periphery, you go to the ribbon at the top, add network device, and you will see here Modbus server. This is supported in Gen 1 and Gen 2 mini servers. So I am going to select Modbus server. Once I've selected Modbus server, I'm going to give it a name. I'm just going to call it Coolmaster Net. I then need to fill in the IP address for this unit, which is just here. So I'm going to take that IP address and put it in there. You also need to add in a port number for Modbus IP. Now, certain Modbus devices will allow you to change the port number. Some won't. If you can't change the port number will be 502, which you can see it's actually automatically added for me once I clicked off there. There's a couple of other options you can set as well, whether you want a delay after start. I like this. It basically just means when does it start trying to communicate with the device if the mini server reboots. I like having a little bit of delay in there, otherwise it can lead to the device showing as offline for a few seconds. And then the timeout is how many basically missed pings does it have before it shows you the device offline, which by default, 5 minutes. And fragmented packets, to be honest, I've never had to tick it, so I'm just going to glaze over it. So that's the main device added. Once you've added the main device, you then add, once you've added the server, you then add a device to that server. So we're going to add in a Modbus device. This is still the Coolmaster. So you have the server, which is basically the IP address it connects to, and then the device under the server, which is the specific thing you're talking to. So again, fill in the name of whatever it is, Coolmaster Net. You've then got a Modbus address. That's because you may have one main server with several devices on it. And remember, Modbus is an addressable system. If it's just a single device, single address, it's probably address 1, which in this case it is. Brilliant. We then need to start adding in registers. Now, registers are the way that Modbus works. It speaks on registers. Registers can be anything from 0 to 65,536. So if you do not have an integration guide or a registers guide from that manufacturer, it is a 1 in 65,000 chance of getting what you want. We can't help you. Unless you come to us with a manual with those registers, there is nothing we can do to help. Now, with Coolmaster in particular, they do have a registers list readily available. And luckily for you, I have made this integration guide that actually breaks those registers lists into their most important ones. Now, the way that Coolmaster works is because it can communicate with loads of indoor units, what they do is they use a base 16 code or a 16 multiplication factor for all of the addresses. So indoor unit 1 would start at register 16. And then it would move up from there for all of the other commands you have. Indoor unit 2 would start at address 32. And you add 16 every time for the starting address. So on and so forth ad infinitum. And that's how you can communicate with different indoor units. So first thing I need to know is which indoor units do I want to connect to? Now, I would pick the on-off. If ever you're going to do any testing through an aircon unit, pick on-off because it's the most easily noticeable one if you get it wrong or not. So we're going to pick on-off, which you can see for indoor unit 1 is 19, indoor unit 2 is 35, because you can see here I've worked it out. If you go beyond virtual address 5, easiest way to do it would just be to make yourself a spreadsheet and then just take the indoor unit number and multiply it by 16. That'll tell you the base address, and then just add 3 to the base address, and that's your on-off number. So I've got all of these that are potentials, and I want to find out which unit is which. For testing purposes, what I would do is, if I haven't already done it on the Coolmaster by pressing the on-off button, I would create a switch block for each of my indoor units, create the register, put it on the switch block, and in the app, turn them on and off one by one and listen to which units turn off and on. Now, I've already done that in our office, so I already know that the room that I'm sitting in here is virtual address 5, which means that my on-off register should be 83. So let's see if I got this right the first time. So I want to create myself a register. Now this is going to be an actuator because we're controlling it. So I want to select actuators, ribbon at the top, analog actuator. Most of the time, we are going to be talking about analog registers with Modbus. It will be, or it should be, written in the documentation of the unit, if not. So this is going to be VA5, did I say? So virtual address 5, on-off. I said that the address was 83, the register was 83. So in IO address, I'm going to fill in 83. I also need to know the command type. Again, that should be written in the manual. I believe I have put it in here. I hope I've put it in here. Oh no, I didn't fill it out in my guide. Did I fill it out in my guide? How good have I been? I didn't fill it out. So naughty of me. I think I didn't fill it out because it's the default that it gives you. But I have put a link to the registers list anyway. So if we take a look at the registers list, yeah, big, long, complicated document, blah, blah, blah. Here we go. Holding registers. Yeah. So you can see here, it's showing base address 0, And you can see all of these different ones here, and you can see that it writes it as holding registers. Holding registers, if we look back in config, we've got the option of coil or registers. So because it says register, we pick the register option. Perfect. And then registers can be 16-bit or 32-bit. Again, if it doesn't detail it, they're probably going to be 16-bit, and they can be signed or unsigned. Unsigned means that you can only do positive values. So you can do from 0 to 65,000. Signed registers means that you can do negative and positive values. So you can go from negative 32,000 or negative 32,500 to positive 32,500. Again, if it doesn't dictate, it's probably an unsigned. So that should be all I need to do. Register, the command, the data type, drag it out, connect it there. This is actually VA5. Save it in. While it's saving in, switch my camera over. And then hopefully you can just about see the left-hand side of this camera image. I'm then going to go to the web interface. Which is this one here. And in my living room, I should have that switch that I made. Here it is. And here's the moment of truth. Is this going to turn on? Ta-da! Look at that. Left-hand side, it's just turned on. Turn the switch off. And it turns back off again. Boom. So there is our testing period done. We now know that that is the correct unit for us. So we're on unit 5. So I can actually now get rid of this switch block. Don't need it anymore. So now I'm on to, okay, which registers do I actually need to communicate properly with this aircon unit? I obviously need to be able to turn it on and off. As well as being able to turn it on and off, the other things that I can tell you straight away on every aircon unit you will need to be able to set is the operation mode. The operation mode is whether it is in cooling mode, heating mode, or automatic mode. Because as well as turning it on and off, you need to be able to say which operation it's going to. So that is an absolute must. On nearly all aircon units, you are also going to need to set the fan speed. Because pretty much every aircon unit has different fan speeds. And on most aircon units, you will also need to set, generally speaking, the set temperature or the temperature set point. So that is, if I just save that, just create that before I explain, the temperature set point, what that means is if I go back to the app and turn this back on again, you'll hopefully just be able to see there that it says 22 degrees. That's the set point. That's you telling the thermostat what temperature you want this area to reach. So that's going to be an absolute must as well. And then the final bit, which you might need to set, we don't on our particular aircon system, is the louver position. The reason we don't need to set a louver position is because we have ceiling mounted vents that have no louvers. On an on a domestic AC unit, you might have those louvers that move up and down and you need to set a louver position. I normally just have it constantly pointed up. That's my personal preference. So I just put a constant onto it. So just to double check against my document to make sure I got that right. Operation mode, fan speed, set temperature, on off. Perfect. So operation mode is the first register, which we can see from VA5, which is the one we're on, is register 80. So operation mode, register 80. Perfect. And I'm going to drag it out. Next, fan speed, 81. So fan speed, 81. Drag it out. And then finally, temperature set point. Now, this is where we get a little bit interesting. When we do temperature values on things with Modbus, whether it's an AC unit or a heat pump, doesn't really matter. Modbus through signed and unsigned registers can't go to decimal values. It can only do whole values. And of course, depending on the unit that we're speaking to, we may well want to set something like 21.5. So how do we achieve that? Well, the answer is on most Modbus devices, you multiply the number by a certain value. With Coolmaster, you multiply it by 10. So if I want that to be 21 degrees, I would actually send it a value of 210. We can do that very, very easily. To register 82, we can do that very easily just by using correction. So input value to 10, target value to 100, meaning if I give it a value of 10, I want it to output a value of 100, and that will scale it itself. And that is then the temperature set point. So for every AC unit, these are the 4 you need. And then for a domestic one, you might also need the louver position. I'm not going to show you how to create the intelligent room controller or climate controllers or anything like that because there is already a video on this. What I'm going to show you specifically is how to configure the aircon onto these blocks. So first of all, if we are talking about our climate control and the function blocks related to it, the first of those function blocks is the climate controller, and that is what we're going to use here as well. I already have a climate controller here on the whole house heating page for the boiler. I should not add anything to do with the aircon onto that climate controller because one climate controller should not be controlling both a boiler and an aircon unit. They are 2 different sources. So for every source of heating and cooling, you should have a climate controller. So I'm going to add a new climate controller specifically to this room. And in this office, we have a climate controller for every single room in this office because every single room, even though it's one aircon system, because they're different indoor units, they operate as different sources. So add in another climate controller that is specifically for your aircon. Then parameters. This should be set to simple control oil/gas. The reason being is it is simple control. I am literally just turning something on and off. I'm not doing any complex settings to this aircon unit, turning it on and off, so it's simple. The mode, I'm going to leave at 0. 0 means it can do heating and cooling. If you only want this aircon unit to ever be able to do cooling, you can set the mode to 2. You could also set the energy costs if you would like. I'm going to forgo that for now because this is a commercial environment. I do want the aircon unit to come on for cooling and for heating. But if you were doing a domestic, you could say that it's expensive for heating. And then include outdoor temperature. Again, we went over that in the heating webinar, so I'm not going to go over it again, but I don't have a weather service, so I'm going to untick that. So what's this aircon unit need to do? Well, it needs to turn the aircon system on and off. So regardless of whether we're in heating or cooling mode, the aircon needs to turn on or off. We also need to set the operation mode depending on heating and cooling. So back to our registers list, operation mode, we send it a 0 if we want to be cooling and a 1 if we want to be heating. So best way to do that, probably a status block. So we're going to have a status block for our operation mode. Don't need the status block to be seen in the app, however. So H is going to go to AI1 and C is going to go to AI2. If AI1 gets a value of 1, so if the climate controller is telling it to heat, it should output a 1. If the climate controller is giving it a cooling signal, so AI2 equals 1, it should output a 0. And that is then operation mode sorted. Next, we have temperature set point. This one's actually nice and easy. There's already an output on the climate control on the room controller for this called AQT. output AQT on the intelligent room controller tells you what the current target temperature is. Just stick that straight there. And then finally, we have fan speed. Fan speed depends particularly on the unit. On a Samsung unit, you have 0, 1, or 2 for whether you want it low, medium, or high. So 0, 1, and 2 for low, medium, high. I find personally with most aircon units that when they're on high fan speed, it's a little bit intolerable. So I, generally speaking, will only do a low or medium fan speed, and then I might do a high fan speed if there is a particular need to, like it's really, really struggling. And we can do that quite cool as well. Through, you guessed it, another status block. Status blocks, great for doing this kind of conditional logic. So this is going to be our fan speed. So where do we get the fan speed from? We know that the register from the aircon is going to connect here, but what is telling it different fan speeds? Well, the closest analog we have to fan speed on a normal heating and cooling system is the valve actuator position. So that's where. We, however, will not take it from the same output where our valve actuator for the heating is connected, because this is only ever going to do heating. What we actually have to do is connect this climate controller for the aircon onto the intelligent room controller. So you can see double clicked on the intelligent room controller. Here's our aircon climate controller, add it in, tick that it can do heating and cooling, press OK, and look at that, I now have an HC2 output. So that is a heating and cooling output linked to climate controller number 2. So that's where I'm going to take it from. And that's going to go to my status block. Then I did say I wanted the high fan speed as well in certain circumstances. So how am I going to do that? What do I want to define when I should be at a high fan speed? Now, what I found best in this office is that we only want it to go to the highest fan speed if the aircon is struggling to get the room to a specific temperature. And the way that I've defined struggling is it's been on for a long time. And the climate controller actually has an output built in for this. So there is a parameter on a climate controller called T2, which is delay for stage 2. And if the climate controller has been on for this amount of time, it activates a secondary stage. So I've put that in our office to 120 minutes, 2 hours. So if the aircon is on for 2 hours, it means it's struggling. If it's on for 2 hours, that will then activate the secondary stage. So you can see here, C2 and H2 for second stage. So then H2 and C2, I want to connect to AI2 because that's our second stage. Then, final bit here, just need to actually fill in this status block. So first of all, if the second stage equals 1, so if AI2 equals 1, then we want to send that fan speed to its highest value, which is 2. Then for the rest of it, we're between 0 and 1. And that is coming from AI1, which is our normal valve actuator output. And whichever scaling you want to use for this is entirely up to you. But I would generally say that if the valve actuator is giving it a value, because remember it's analog, so it's 0 to 10. If it's giving it something greater than 0, but maybe less than, let's say 7, it goes to the lowest fan speed, which is 0. If the valve actuator output from the intelligent room controller is maybe greater than 7, that's when it goes to the medium stage. And that is then the fan speed's done. Okay, that. And then the very, very final bit before I save this in is a little thought experiment. If I were to save this in, all of a sudden, this climate controller, this system here is going to start sending values to the aircon unit. The problem is depending on the aircon unit, it might have a certain order that it needs to receive values in. For instance, it might need to be on before you can send it the operation mode or the fan speed. So how do we get around that without adding loads and loads of delay blocks in? Well, the easiest way is that on all of these registers, there is an option to send regularly. And if you fill that in, then regardless of whether there's been a change or not, it will resend the value every X amount of time. So I could say that every 30 seconds on all of these registers, it resends the value just in case it missed it first time. So every 30 seconds on all of these, resend that value. And after all of that, that should be a fully working aircon system. So to finish it off, let's just check that we're in a heating and cooling schedule, which we are. Let's see what our heating and cooling set points are. So I probably want the comfort for heating to be maybe at 21.5. Comfort for cooling, maybe at 23. And then the eco band, yeah, that should be fine as is. So what I'm hoping is this room is currently 28 degrees. I said I was getting it nice and toasty in here. Because we are well above our comfort cooling temperature, it should pretty much instantly come on to cooling mode and try and get us back down to 23 degrees. So let's see. Save in mini server. Now, the climate controller and the intelligent room controller do have an inbuilt delay of about 60 or so seconds. So we might have to wait a little bit of time before this kicks in. But what I should hope to see is this climate controller outputting a C, which will turn the aircon unit on. The intelligent room controller outputting the desired temperature and also a particular fan speed, which this status block should interpret to be value 1, which will be the medium fan speed. So might have to wait for it for a minute or so. Let's just give it a second. And Alan, yeah, I never promised it was going to be easy. We are starting to talk about some pretty complex integration through Modbus. It is what it is. There we go. So check this out. You can see there on live view that everything just reacted. It sent a cooling demand to the aircon unit. It has sent a value of 10 from HC2, which the status block is translating into 1, which, as you remember, is the second fan speed. It's also sending a value of 23, which it's converting to 230 to the aircon unit. And as you can see over here on the thermostat, it worked. If I stop sharing my screen, just to really prove it, look at that. Let's try and get rid of that glare. Oh, don't know how well you can see, but it's in cooling mode. It's got a set temperature of 23 degrees, and it is on the second fan speed. So all of that configuration worked perfectly. Aircon in the room is now on, and it is working, and I can feel some glorious cold air coming down on me. And there we have, start to finish, a fully commissioned aircon system. Just to recap on all of that, because I know there was quite a lot there. Connected to the Coolmaster unit. Done the settings on the Coolmaster unit so it finds the various aircon units we have, and each of those aircon units has a virtual address. We've then worked out which virtual address is which, and in this particular room, we are virtual address 5. We then, for every aircon unit, need at least 4 different values. We need the fan speed, the operation mode, the temperature set point, and on/off. So we need to put in the correct register for each. We've also filled out that it regularly resends value to the aircon every 30 seconds, just in case something was missed. And for any temperature values on this particular unit, we have to multiply by 10. So if we're sending it a 10, we want it to send 100. Then we take those out. The on/off command connects to your climate controller, to both H and C. Your temperature set point connects to AQT on your intelligent room controller. Your operation mode connects to a status block. The status block is looking at the H and the C outputs from your climate controller. If it is getting a C, it sends a value of 0 because 0 is the cooling operation. If it's getting a value of H, it's sending a 1 because 1 is heating mode. Then we're taking our valve actuator output linked to our aircon system into another status block. And we are then changing the 0 to 10 output into a value related to a fan speed. On my particular config, I don't want it to go to the highest fan speed unless the aircon system has been on for 2 hours. So I'm looking at the second stage heating and cooling outputs here. And I've set a parameter here of 120 minutes. So this has to be on for 120 minutes before either one of these will go on, which the status block is then converting to the highest fan speed. And there we have some working aircon. And all I now need to do is replicate this for every single room in the building. And yes, it will take a significant amount of time the first time you do this. But when you've done a couple of systems, then just like me, what's that? Start to finish on the config side, 30 minutes. And that's with me talking. So I could, without the talking in 20 minutes, configure a room. In this office, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different spaces. So 200 minutes, I would have been done on this config. I don't think there is anything else for me to really say. Questions and answers time. Let's get cracking. So, Rob, where can you purchase the Coolmaster nets? Will Loxone be stocking them? No, Loxone stocks Loxone equipment. If you want to purchase a Coolmaster unit, you can purchase it from a company called 10 Ways. So this website just here, I think is a 10 Ways website. So Coolmaster unit you purchase from 10 Ways. To be completely honest, I don't know where you purchase Intesis from in the UK. I think they're stocked at Ivory Egg and my KNX store. John has asked, once it gets to the set point, does the AC switch off or can it go to fan only? The answer is it honestly depends on the particular AC unit. For our particular AC unit, it actually doesn't matter what you set the set point. I could set that to a set point of 80 degrees if I wanted to. If I've told it to be in cooling mode, it'll only blow out cold air. And it'll actually wait until Loxone stops telling it to be in cooling mode and stops telling it to be on before it actually stops, which is great because it means that it really doesn't matter what temperature set point I send it. I could just send it a constant of 10 if I wanted. It doesn't matter whether it's heating or cooling, and it will respond to Loxone. And of course, Loxone in the background is learning and knowing what it should do. So it will be tailing down the fan speed as you get closer to your set point. And then once you reach it, it'll turn off anyway. Nick, why don't you use the sensors as return values to confirm fan speeds on, off, etc.? This is what you need to use if there is no wall thermostat. Yeah, I could do. So in the same way that we are sending values to these registers, I could actually just create it as a sensor. So I could create an analog sensor for the fan speed using the same register number, but this time under sensors, not actuators. So it's 81. So in here, IO address 81. And again, it's probably actually this time going to be a holding register because again, from their document, I believe it said holding registers. And I could read that if I wanted to. I have absolutely no need to though. Yeah, it could give me a little bit of feedback that it's working if I didn't have thermostats on the wall. But I've got ears and I've got skin. I can hear that it's working. I can feel that it's working. I can hear blowing. I can feel cold. So for me, the sensors is redundant. But yeah, you can see you can also read the status of all of these registers as well. You can read the current temperature that's being read from the indoor unit. However, if you've got a proper Loxone system with a touch switch or a touch pure, again, why would you? Because that's going to be more accurate. So before we had the demo case here with the touch switch in, I was reading the temperature from the AC unit, and it was always out by about 2 degrees. So hence why I'm reading it from a touch switch. But Nick, to be honest, I just don't really see the need to read the registers. If it works, it works. Keep it simple, stupid. LiveU, how easy is it to integrate with Daking air conditionings? It's exactly the same. Nothing changes. That is the beauty of using an integration unit like Coolmaster or Intesis. The make of Aircon system you're talking to does not matter. It is exactly the same. It's the same registers, the same commands, the same config. That is why we use the integration box in between. For the Intesis, I know we haven't actually had enough time to look at that, but it is genuinely, the config is identical. The only things that change is that you use the Modbus extension because it's Modbus RTU, and the registers are different, but it's all documented on their data sheets. I believe we actually even, Modbus extension, have a device template for a couple of the Intesis units. So here's their Daking one. So Daking AC, select that, and you can see that the register numbers might be different, but on off, operation mode, temperature set point, fan speed. All of those are exactly the same. Control disablement, probably don't need it. Humidification value, probably don't need it. Vane position, might need that one. Operation time, probably don't need it. Window contact, probably don't need it. The only ones you need, on off, operation mode, set point, fan speed, and maybe vane position. Everything else is just a bonus. Shucks, yes, for the Coolmaster, because it's Modbus IP, it just needs to be connected to the same network as the mini server. So Ethernet into a router, a network switch, whatever, on the same network. So you can see here that, here's the IP address of the Coolmaster unit, and the mini server is 10.74.2.37, so same network. Let me just go back through the other questions. Dean, if you set temperature in Loxone, will it auto update if somebody changes the temperature on the control panel in the office? That is a really good question. Let's test it. So back to the other camera. Stop showing my screen. You can see at the moment that it's set to 23 degrees. That's what Loxone's telling it. Let's change that to 19 degrees. Okay, I've successfully changed it to 19 degrees. And let's wait 30 seconds and see what happens. Maybe even a little bit less than 30 seconds. And what should happen, there we go, ta-da, goes back to 23. The reason is because on my config, I have set on temperature set point that it resends the value every 30 seconds. So if you fill in the send regularly, then yes, it will overwrite what the customer tries to do on the thermostat itself. The thermostats themselves, what I would actually do personally in our office, and we will be doing this, I'm going to keep them because we've already got them, but I'm going to move them all to the plant room. So they're going to be there purely for maintenance purposes and for a visual check if I ever feel the need to, but they're not going to be on the walls in the rooms. The send regularly is really, really useful. I would not recommend, however, that if you have 1,000 different registers for 100 different aircon units, that you're resending a value every 5 seconds on all of them. You're going to create some issues doing that. Be sensible with it. Cool. Has anyone got any other questions? And remember as well, if you would like to ask me anything directly via microphone, use the raise hands feature. and you can. Otherwise, I'm going to send over the poll for the next topic. You'll have to forgive me. I didn't remove air conditioning from it, so please just don't tick that. Oh, shucks, good question. Can you remove the manufacturer's controllers completely? Yeah, why not? We're the thermostat instead. So I'm going to send over the poll for the next session. Please fill in what you would like to cover on the next session. You'll notice the poll is getting shorter and shorter. Please, 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 we want topics to cover. We want to show you guys things. Please email your partner coach with what topics you would like to cover. We want more topics to add to this poll. If we don't get more topics to add to this poll is going to get significantly shorter and shorter and shorter each time we do this webinar, which is not good. We want topics, send them in. But please fill in those topics for now. And whichever one wins will be what we cover in the next session in another 3 weeks' time. Does anybody have any questions in the meantime? Any final questions from anyone? So yeah, it's a little bit complicated, but hey, you're integrating with something else. Main thing though is it is working beautifully. It is nice and cool. Carl, will the guide I created be sent out? It already was about 2 months ago. So this is a good reminder for everybody that if you are not already on the Loxone partner WhatsApp group, to please add yourself to it, because these various guides and integration documents are sent out on this WhatsApp group. So go to this website here and you'll see the instructions. Otherwise, yes, it is also available on the Loxone Academy. Everything we create, it isn't just thrown into the ether and then is never available to reference again. academy-uk.loxone.com has all of the content that we create. Every one of these webinars is recorded and put on there as well. The WhatsApp group is generally the first place that these are sent to. So both of those, both of those resources, incredibly important. There is going to be a boatload of stuff posted over the coming months. We want to be providing every single conceivable piece of helpful information we can to partners, but we need partners to read it. It needs to be read, otherwise there's no point in me creating it. Adrian, presumably H2 and C2 are either on. Nope. And nope. We're on the medium fan speed, not the high fan speed. 1 is the medium, 2 is the high. Oh, either or, yes, sorry. Because they're both connected to AI2, it is just looking for one of them. Either of them can activate the high fan speed, which is correct because we want it to go to high fan speed after 2 hours, whether it's heating or cooling. So WhatsApp group, Loxone Academy. I'm going to send the link to the Academy in the chat. Everyone, Silver Partner and above, has access to that already with the email address you use to log into the web shop. And then there is the link to find out the details about the WhatsApp group. Oh, integration of Velux electric windows with an aircon system. Yeah, I think that's a one-on-one topic. Get in touch with your partner coach, because what we need to understand with that particular one is we need to know what the use case is. So what exactly you want to happen. But yeah, it's going to be fairly straightforward to work on. Just give us a call, send in an email. Happy to help with that. All right, I think that's it for me. It's been a pleasure, everybody. And I'm just going to end the poll. I will catch you next time. Goodbye.